Hello, thank you for participating in the log difference user study. In this tutorial, you'll need to perform the test of log difference. So let's start from defining a log. A log is produced by a system, a software system, and consists of a set of execution traces. Each trace corresponds to a single run of the system. Traces are composed of point events. Each event documents a single action that the system made and was documented. So let's consider a toy example of a log. The following log consists of 3 traces. Traces are separated by 2 minuses. The first trace consists of 3 events, event 1, 2, and 3. The second trace consists of event 1 and 2, and the third trace consists of event 1, 2, and 4. In this user study, you'll need to compare between different execution logs. So not just one log, but several logs. And the way that you'll be expected to do that is by focusing on the differences of 2 sequences, where a 2 sequence is simply an occurrence of 2 events that appear run one after the other. So let's consider the 2 sequences that appear in the log we've seen above. The first trace, event 1, 2, and 3, consists of 2 event sequences, event 1 and event 2, and event 2 and event 3. The second trace consists of event 1 and event 2, single 2 sequence. Lastly, event 3 consists of 2 event sequences, event 1 and 2, and event 2 and 4. So the log simply consists of all of the unique 2 sequences that appear in the traces that it includes. Therefore, it consists of event 1 and 2, event 2 and 3, and event 2 and 4. In the following tasks, you will need to compare between different logs and find whether there are any 2 sequences that appear only some of the logs. In this user study, you'll receive 6 tasks. Each task corresponds to a different system. To each system, you receive 5 logs that were produced from daily runs of the system. So 5 logs for 5 consecutive days of the system. In one of those days, a new version has been deployed. You're kindly requested to answer the following questions with the tools that we will provide you. The first question: does the new version allow for a new 2 sequence? Second, if so, what is the first log to contain the new 2 sequence? Third question: please specify a 2 sequence that appears in the new version but not in the old version. If you don't find any 2 sequence, just mark 1. If you find more than 1 2 sequence, you can simply specify one of the 2 sequences. We'll have a drop down to mark the events. Lastly, if you find a 2 sequence, please copy a single trace that shows this 2 sequence and paste it in the dedicated place. To demonstrate the notion of a 2 sequence difference between log, let's consider 2 logs, L1 and L2, which we will compare to the original log we've had at the top of this page. Consider L1. It consists of 2 traces, event 1, 2, and 3, and event 1, 2, and 4. The 2 sequences that this log contains are therefore event 1 and 2, event 2 and 3, and event 2 and 4. These are exactly the same 2 sequences as the ones that we extracted from the first log. Same set of 2 sequences, and therefore, even though the 2 logs are not identical, they do not contain any 2 sequence difference between them. Let's move on to the second example of log 2. Log 2 consists of 2 traces, event 1, 2, and 3, and event 1, 2. And the 2 sequences that it contains are event 1, 2, and event 2 and 3. Notice that event 2, 4 is actually missing from L2, and that would be our two sequence difference between L2 and the original log that we have had in the beginning of this page. Now in this tutorial, you'll receive several tools and will be expected to use each of these tools in order to try and answer the question presented to you above, questions 1 to 4. To illustrate the tools, we will compare between L2 and the original log and demonstrate each of the three tools that you will be using today. The first tool is a diff checker. You can use this tool by copying the logs into the text areas inside this web page and hit the Find Differences. This will find any textual differences between the logs, which can then be used in order to identify where the new to sequence appears. For example, we can see event 2, event 4, the to sequence was actually marked by the tool. The second tool runs the K-tails algorithm. This algorithm obtains a log of execution traces as input and outputs a finite state machine, which captures the behaviors that are seen inside the log. Any trace that appears in the log can be played by the K-tails model. But the K-tail models can obtain more traces than the ones that appear inside the log. To run the K-tails algorithm, you can copy-paste the log into the dedicated text area and hit the Submit button. And this is the model that we obtain. What K-tails guarantee to us is that any transition that appear in the model must also appear in the log. So if event 1 and event 2 are connected, they must also appear somewhere in one of the traces inside the log. Now let's construct a K-tail model from the second log, L2. And let's compare the two models. As you can see, we can identify there's a difference. And if we look carefully, we can identify that the branch event 1, event 2, and event 4 is only apparent in this model. This can hint to us to where the new to sequence appear. The last group of tools, KT-diff and diff-KT, are used in order to perform log differencing. These tools use the K-tail models in order to perform the log comparison. So if we copy-paste the original log to the left side and the log L2 to the right side and hit Submit, we'll obtain the K-tail model, but this time with labels over the transitions. I remind you that the K-tail model has a transition between two states only if they appear somewhere in the log. So K-tails illustrates which transitions comes from which logs and highlights in red the ones that only belong to some of the logs. In this case, we can see that the original log is the only one to contain the branch of event 1, event 2, and event 4. diff-KT also uses the K-tail algorithm to perform log differencing, but in a different way. diff-KT first constructs the K-tail model from each of the logs separately. Then it searches for two sequence differences between the logs and for traces that include those two sequence differences. Finally, it highlights those traces over the corresponding models. So let's see this with our running example. And as you can see, diff-KT is able to detect that there is a single to sequence, event 2, event 4, is included in the trace event 1, event 2, and in event 4. And it highlights it over the corresponding model with the red transitions. Notice that the solid red transitions are a part of the to sequence. In the case that there are two sequences that only appear in the second log as well, we will see this with the corresponding model for the second log. So as you can see, we added a new event sequence, event 2, event 6, 2 sequence, and as you can see, the corresponding model of log2 appears and highlights that 2 sequence difference. Each 2 sequence difference is guaranteed to appear in a corresponding trace, so there may be several traces in the text areas you see here, but only one of them will be highlighted over the model. If you wish to experiment with the tools yourself, you can select one of the examples and run the tools. For example, let's take example 1 and ktdiff. Let's select 4 logs for comparison. If we hit submit, we will get the model that highlights 2 sequence differences, like the ones that we see here. Thank you very much for your attention, and good luck on your set of tasks.